So what we have here is a function on the xy plane, which is the dotted red line, and that's equal to y equals 4 subtract e to the power of a fifth x. Okay, so you can see that it creates a decreasing function, and what we're going to do is we're going to rotate that function between the lines, so x equals 1, not x equals 2, and x equals 5. We're going to rotate it around the x-axis by 360 degrees, and we're going to therefore create a solid from volume of revolution. So to do that, what we're going to do is consider this little disk, which has got a thickness dx, and it's got a height, rather a radius, because it's a circular disk, y, from the x-axis up to this point here. So to work out the volume of that little disk, we're going to say that it's going to be multiplied by pi times the radius squared, or y squared, will give me the area of the disk, and then multiply that by its thickness dx. So if we can then integrate this function pi y squared dx between x equals 1 and x equals 5, so effectively we're going to integrate between 1 and 5, and we're going to take our pi outside, y squared dx. Now we know that y squared is going to be our function up here, squared, so therefore we're going to integrate pi integral between 1 and 5 of y squared, which is going to be 4 minus e to the fifth x all squared dx. Okay, so we're going to do that separately, so that's my introduction. So here's our function once again, for y equals 4 minus e to the 1/5 x, or 0.2x in this case, and you can see our little volume element d with thickness dx exaggerated. So effectively we've shrunk that right down to create a very small disk, and then integrated between x equals 1 and x equals 5. So I'm going to remove that volume element, and then I'm going to put a trace on between our two limits, so between the 1 and the 5 along our length of our curve, and then I'm going to rotate this set of points around the x-axis by 360 degrees, thus generating the solid for which we're trying to figure out the volume by using our volume of revolution integration.
Okay, so now for the tricky bit, the actual integration itself. So you remember our function was y equals 4 minus e to the 1/5 x, and we were going to integrate that function, multiply by pi outside between 1 and 5, and it's going to be y squared, which is 4 minus e to the 5th x all squared dx. So the first thing we need to do is multiply our function out. So I'm going to move that over here. I'm going to expand 4 minus e to the 1/5 x squared. So if I expand that out, I'm going to get 4 times 4 is 16, multiplied by 2 lots of 4 times e to the 5th x. So I get 8 e to the 1/5 x, and then I get plus, multiply negative e to the 5th x squared, so it becomes plus e to the, so we're going to get 2 lots of 1/5 x, so it's going to be 2/5 x. Okay, so there's our function. So now we're going to perform our integral between 1 and 5. 16 subtract 8e to the 1/5 x plus e to the 2/5 x dx. So term by term, put in our square brackets, 16 becomes 16x, and subtract. Now we're going to be dividing by our 1/5, so it's 8 over 1/5, which is effectively 5 times 8, so it's going to be 40 e to the 1/5 x. Remember, the power in the exponential doesn't change. And then we're going to divide through by 2/5, or effectively multiply by 5 over 2, again e to the 2/5 x. Our power not changing between our two limits, 1 and 5. So all we got to do now is throw our values in. So it becomes pi times 5 times 16 is 80 minus, now I'm going to put 5 into my exponential here, so it becomes 40e to the 1, or just 40e. And then I'm going to put 5 into here, so that's going to be plus 5 over 2e squared. And then I'm going to subtract everything with 1 substituted in. Okay, so subtract small brackets 16. That becomes minus 40e to the 5th. Okay, we're running out of space, and this is going to become plus 5 over 2e to the 2/5. Okay, and we're going to shut all our brackets down and move up here and tidy things up a little bit. Okay, so we now just have our pi on the outside. Okay, and inside we've got term by term 80 subtract 16, which is going to be 64, and then we've got negative 40e, and that's the only power of e that we can actually put with that, so it's going to be minus 40e there, plus 5 over 2e squared, and then we've got subtract negative 40 e to the 5th, and then finally subtract 5 over 2 e to the 2/5. Okay, so we have our exact area. All we've got to do is plug all the values in to get it to the correct number of decimal places. So I'm going to finish that off in a minute, because I'm just going to do the big reveal on my my program that I run where I show the revolution. Okay.
So here we are back to our solid of revolution. So as I promised, a big reveal. So what I'm going to do is click on my reveal volume button, which will give me the volume to 2 decimal places, I believe. Okay, so if we check this out, we get a volume of 59.28. Okay, so hopefully that corresponds to my exact calculation, which I will check and confirm. So, having run my result of my integration, this horrible looking result with lots of exponentials through the online calculator, I notice I get an approximate decimal value of 59.28, which is in exact agreement with the value that the Volume of Revolution app showed me.
So, as you can see, after we performed the integral of 4 minus e to the 5th x all squared dx multiplied by pi, we ended up with the exact value, as you can see above. That exact value is actually quite an unpleasant exact value, so in this case I would be inclined to simplify it to a decimal to 3 significant figures. So we had a final value of 59.3 centimeters cubed, or cubic units. Okay, so I hope you enjoyed that, and we're done.